Good morning, everyone watching the program. Good morning, grade 12 learners. Good morning, teachers. My name is Mohapi, and I'm going to be focusing today on the preparation for the exam, paper 1. I hope you are all ready. Everyone is ready, prepared to take some notes, and we'll do some few exercises. As I've already indicated, we'll be focusing on the preparation for mathematics paper 1. So I'll try and cover the crucial topics, because in 2 hours' time, I don't think it's possible for us to cover all the topics, but I will try and cover most of the crucial topics that learners must be aware of. I hope at the end of the lesson, everyone will be inspired, and I hope even the lesson itself will be very much successful. Thank you very much. I think we should now start. Thank you. Like I indicated earlier, Mathematics Paper 1, exam preparation, and my name is Mohapi, working as the subject advisor here in Motel District. Thank you. Let's check about the exam dates. Just a reminder, I know all the schools must have received the timetable by now, but specifically for mathematics September examination, we have 2 dates. On the 12th of September, then learners will be sitting for mathematics paper 1. It will be out of 150 marks. And the duration will be 3 hours, starting from 9 o'clock until 12 o'clock. That's why we always emphasize the importance of time. Time is really key. You can see again, even on the 15th of September, it will be on Monday. 12th will be Friday. 15th will be on Monday, 15th September 2014. Learners will be sitting for mathematics paper 2. It will also still be 150 marks, and the time from 9 o'clock until 12 o'clock. I hope you've got their dates ready. I'm talking about the September examination right now, because I believe we need to prepare thoroughly for these September examinations. We need to score high marks as learners. We need to ensure that we teachers, we need to ensure that our learners perform well in mathematics, because September examination contributes 25% of the SBA mark. So 25% is lots of marks. So we need to make sure that our learners get good marks so that their SBA marks can be good. As a result, this increases their opportunity. This increases the opportunity of them performing well at the end of the year. Thank you. You've got your dates, you've got your papers correctly, the duration and the total marks. You've got everything as is indicated in the screen there. I hope everyone is now ready. Thank you. I'm going to focus mainly today. My focus will be mainly on mathematics paper 1. I'm going to give tips here and there on the possible questions and how to answer those questions, and the common mistakes that are done by learners in mathematics paper 1. Take note. Let's talk about mark distribution first. Bookwork. Bookwork, it takes a maximum of 6 marks in paper 1. So maybe learners won't understand what I mean when I talk about bookwork. Basically, bookwork is a question whereby learners can be expected to derive the formula for, say, for instance, arithmetic series. I hope you know the formula. Bookwork, 6 marks. Let me show you this. Bookwork, remember, formula for arithmetic, summing arithmetic sequence as n is equals to n over 2 into 2a plus n minus 1 d. But a bookwork, we mean there's a possible question whereby learners can be asked to derive this formula. Or sometimes it can be as n is equals to a into r exponent n minus 1 over r minus 1. That is a formula for summing up a geometric series. That is a formula we use for summing up a geometric series. So this is just an example of what we mean by bookwork. So for paper 1, the maximum marks on this topic, on bookwork, will be 6 marks. So teachers, let's prepare our learners properly. Give them exercises to go and derive either the formula for summing up arithmetic or geometric series. Learners must know that. And I believe if learners know how to derive the formula, then they will understand properly the contents of the sequences and series. because they will know how to derive the formula and they will understand where the formula comes from. As a result, dealing with problems related to that particular topic, it will be easy. Thank you. That is what I only wanted to explain or to clarify what we mean by book work. And in mathematics paper 1, book work takes at most 6 marks. Thank you. Topics. Check on algebra and equations. Algebra and equations, including the inequalities, plus or 25 marks, plus 3 or 25 minus 3. What does that mean? It means in the examination, algebra and equations, we're expecting them to take anything, at most it can be 28, least it can be 22, because I've indicated plus or minus 3. It means you can add 3. 25 plus 3 will give you 28, or 25 minus 3 will give you 22. So basically, the algebra and equations, including the inequalities, the marks will range from 22 to 28. Hence, we have indicated as 25 plus or minus 3. That's algebra and equations. The first question, I believe, in paper 1, that will be the mark allocation. The second topic, patterns and sequences. By patterns, I'm referring to linear number pattern, quadratic number pattern, can be exponential, all those patterns. But the most crucial one, I believe, is a quadratic number pattern that we learned in grade 11. So quadratic number pattern, really learners, we need to make sure that we know our stories when coming to quadratic number pattern, as well as sequences and series. We know we've got basically 2 types of sequences and series, the arithmetic and the geometric. Arithmetic, that's where we have the common difference between successive terms, whereas in geometric, we said we've got the constant ratio between successive terms. So patterns and sequence all together, also plus 25 marks, plus or minus 3. Can add 3 or can subtract 3 from 25. That is the mark allocation for patterns and sequence. Finance, growth and decay. The very crucial topic. Very crucial topic. Check the mark distribution, mark allocation for that topic. That is basically financial mathematics. 15, it can be 12, it can be 18. And learners need to thoroughly analyze the problem so that they should be able to know what is needed and what is not needed. And what is key with regard to finance, growth and decay, the calculation of N. The calculation of N is very much important, because when you calculate N, that's why you have to introduce the log. So it's very much important. Please, let us prepare our learners thoroughly in that case. And you learners, please make sure that you study hard. Teachers can do whatever they can, but as long as you do not study, as long as whatever is being taught, you don't have time to internalize it, there won't be progress. Thank you. Check the next topic. Functions and graphs. 35 marks. Included in these functions, basically functions and graphs, remember we've got 4 functions: the linear function, straight line graph, quadratic function, which is the parabola, hyperbola, and the exponential graph. Those are the functions that I'm referring to. But we also have the inverse functions, the inverse of the log function, which is the inverse of the exponential, the inverse of the parabola, as well as the inverse of the linear. Those are the inverses that learners will be examined on at the end of the year, and again even in September. Check the next topic, differential calculus. If I were to focus mainly on differential calculus and functions and graphs, the 3 topics between them, they carry plus or minus 70. Because functions and graphs is 35 plus or minus 3. Differential calculus, 35 plus or minus 3. So those 2 topics really, they carry lots and lots of marks. And please, learners, let's do justice to the topic. Let's prepare thoroughly for those 2 topics, functions and graphs. And remember, in differential calculus, what is included in differential calculus is also the cubic function. I hope I'm just trying to indicate the mark distribution, what we should expect in September examination as well as at the end of the year exam. June exam might be slightly different because in June you find that some topics have not yet been covered, so the marks will not be exactly as they are indicated in the screen there. But September examination, all the year's work must be covered, so you get a fully fleshed paper. So we believe more or less the mark distribution will be as indicated in the screen. Functions and crafts 35 plus or minus 3, differential calculus 35 plus or minus 3. And between the two topics alone, you already have 70. Thank you. Lastly, we have this newly introduced topic in mathematics, probability. It was initially in paper 3, but now it's compulsory now. It's part of paper 1, it's probability, and it also carries plus or minus 15 marks, 15 plus or minus 3. And if you add them all together, they will still give you 150. I'm just trying to give learners an idea of how marks will be allocated per topic, so that whenever they start, they know exactly this topic weighs so much. But what is important, what I always say, what is important is for learners to target the easy ones first. Make sure that you grab those easy marks before you attempt the challenging ones. Don't forget the bookwork that I said in paper 1, it's plus or it's at most 6. Cannot exceed 6. Thank you. Just for cognitive levels, remember, teachers, you turn to page 55 of the mathematics CHEPS document. It's clearly explained the cognitive levels of papers. So when a paper is said, this means that the recalling part can be about 20%. Routine procedures will then contribute 35% of the paper. Complex procedure, now we're starting to include two or more equations and so forth, 30%. And then the problem solving, whereby we now talk of the application part. It's very much challenging. It's about 15% of the paper. So if learners can prepare thoroughly, I strongly believe they can still get 85%. Because if you exclude the problem-solving part, you still have 85%, and that is still a level 7. That's still level 7 performance. So this is more or less the cognitive levels as will be examined at the end of the year. Thank you. Let me try and give you a better, let me go into details and try to clarify exactly what are the possible questions in the examination. Mathematics paper 1. What is that we can expect? A solve for X question. A solve for X question, whereby you just simply solve for X. And as you can see, it's the simplest one. That's why we said this one is a level 1. That's 20%. A 20% question. Remember the 4 cognitive levels. I said the knowledge, you just recall the knowledge as it is. 3x squared minus 4x equals 0. Simple question that every learner is expected to get marks on that. Because by merely looking at the equation, you can see you just take out the common factor and then solve for X. And it's for 2 marks. 1 mark will be for taking out the common factors. 1 mark will be for the correct X values. Check this one. 3x squared minus 4x is equals to 0. It's one of the possible questions that we should expect. What's going to happen is that maybe the equation might not look like this. But we're going to have a quadratic equation where learners need to solve for X. And quadratic equations have been dealt with since grade 10. So definitely learners, we need to take our part. We need to come to the picture now. We need to start showing that we really determined we want to have a better future. We need to work hard. So when you solve this one, you just take out a common factor. X is a common factor. And then if you take out X, you are left with 3x minus 4, which will give you 0. That's why I said because it's 2 marks. As you can see, the allocation of the marks is 2 marks. The first mark will be for correct factors. And then you solve for X. It means X is equal to 0 or 3x minus 4 is equal to 0. X will then be equals to 4 over 3. The second mark will be for both X values. That's where how marks will be distributed. The common mistakes done by learners. Check. Learners, what they do, the first thing, they transpose. They take negative 4x to the right and then divide by x. That is not the correct way of solving equations. Quadratic equations, you need to take out a common factor. you need to take out a common factor, like it is indicated here. For 2 marks, the first mark will then be for factors, the second mark will be for the correct X values. First question, come the 12th of September, you're going to come across the first question will be solve for X. And it will be a quadratic equation. Not exactly this one, but it will be a quadratic equation. So learners, you need to factorize. In case you are unable to factorize, you can use a quadratic formula. In case you see that I cannot you are unable to determine the factors, you can solve by using quadratic formula. At the back of the question paper, a formula sheet is attached. At the back of the question paper, a formula sheet is attached. So look for the quadratic formula and start using it. The second subsequent question will definitely be the one more or less similar to this one. Check this one. X minus 6 squared plus 2 over x equals to 0. X must not be equal to 0. That is the given restriction, because if x can be 0, you can imagine what is going to happen if you say 2 divided by 0. It will be undefined. That's why x can never be equal to 0. It's clearly in the instruction here. Leave your answer correct. Leave your answer correct to 2 decimal places for 4 marks. And we know for sure, even right now, we know for sure if that even September, even the end of the year paper, we're going to come across a question like that. So what is key in this case is for learners to write the equation in the standard form. Write the equation in the standard form. You know the standard form of a quadratic equation. Ax squared plus bx plus c is equal to 0. Quadratic equation in the standard form. Ax squared plus bx plus c is equal to 0. That's the first step. Ensure that your equation is written in the standard form. And once you see in brackets, if it is stated that you leave your answer correct to 2 decimal places, it's obvious that equation does not have factors. You cannot factorize it. So if you cannot factorize it, we are compelled to use the quadratic formula. We must solve this equation by using quadratic formula. There are those that attempt to solve this equation by completing the square. It's not a problem, it's fine. But the easiest method, go to the formula sheet, copy the quadratic formula correctly, and then you start substituting. Complete the square, yes, if you're conversant with it, no problem. But we're saying our learners are not doing well in maths, and the June results have shown that really we need to work hard as teachers, as learners, as subject advisors, everyone involved in mathematics. We need to work hard to try and improve learner performance. So one way of improving learner performance will then be learners be able to use the formula sheet properly and be able to identify the correct formula. Like in this case, the equation is not given in the standard form. Check 1.1.2. The equation is not given in the standard form. So what do? We write the equation in the standard form. It's x minus 6 plus 2 over x is equal to 0. It's a fraction. We need to multiply by LCD, and our LCD is x. X multiplied by x here, you multiply throughout by LCD, x. You multiply this x by x, you've got x squared. X multiplied by negative 6 gives you negative 6x. 2 over x, you multiply by x, you only left with 2. Is equals to 0 multiplied by x gives you 0. Now the equation is in the standard form. We have multiplied throughout by LCD, which is x in this case. Our lowest common denominator is x. So now that the equation is in this form, we write down the quadratic formula. We are going to use the quadratic formula to solve this one. Let's check. The quadratic formula, x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. The formula is also given on the formula sheet. If you check at the back of the question paper, the formula sheet is given. And in that formula sheet, the first equation is the quadratic formula. Let me show you an example of what a formula sheet looks like. This is what we mean by a formula sheet. Information sheet mathematics. Check the first one. X is equals to minus b plus or minus the square root of b squared minus 4ac over 2a. That is a quadratic formula, and it's a formula that we use to solve quadratic equations, especially those that does not have factors. Make sure that you copy the formula correctly. Do not leave out that negative. Copy the formula correctly. It is there in the formula sheet. At the back of the question paper, information sheet is attached, where all the formulae are indicated. So all what learners need to do, identify the formula, copy the formula correctly, like I did here. Thank you. X equals to minus b plus or minus the square root of b squared minus 4ac over 2a. That is a quadratic formula. After copying it correctly, you start substituting. Check, it's minus. What is the value of b? It's negative 6. Whatever you substitute, put it inside the brackets. Plus or minus the square root of, check the value of b. The value of b is negative 6. Negative 6 squared minus 4. What is the value of a? It's 1. What is the value of c? It's 2. All over 2. What is the value of a? 1. Then you can start simplifying. You've got a calculator, use a calculator until you find the answer. And every time remember the instruction. Leave your answer correct to 2 decimal places. In case the answer is not given correct to 2 decimal places, learners will be penalized. And we don't want to lose marks unnecessarily. We don't want to lose marks unnecessarily. So I'm just saying this is what we should expect in September examination, and also even at the end of the year paper. We should expect such questions. If I were to make an example of another question, I'm not going to solve it for you, because I think when we are at this stage, all we have to do is just to simplify, like this is equal to negative and negative 6 plus or minus. Then you simplify whatever you've got within the brackets all over 2. You square this one, it gives you 36. 4 multiplied by 1 multiplied by 2 gives you 8. And 36 minus 8, I think it will give you something 28. And then the square root of 28 with the aid of calculator, and then divide. From here, you just have to take it off, finish it off. Remember what I said earlier? I'm just trying to outline what to expect in the paper. I'm not going to focus mainly on the solution of problems, but just to say how to solve and the common mistakes done by learners, and what is it that we can do to avoid such mistakes. In this 1.1.2, to avoid mistakes, go to the formula sheet and make sure that you copy the formula correctly. From there, all you have to do, you substitute and then you simplify with the aid of a calculator. There's no learner who can enter the examination room knowing very well that is going to write mathematics and then leaving behind the calculator. It's key. And we need to practice. You need to know practice calculator skills. Thank you. One other possible question that we can also expect is it can be exponential. Remember, this is exponential equation. We can solve that one. Solve for x. X exponent 2 over 3 is equals to 4. What is key? What is key? If you solve x, we only want to be left with x on the left-hand side. We only want to be left with x on the left-hand side. So all you have to do, we need to look at the reciprocal of 2 over 3. And the reciprocal of 2 over 3 will then be 3 over 2. And remember, what you do on the left, you also do on the right. That is one of the possible questions. 1.1.3, I said x exponent 2 over 3 is equals to 4. 4 can be written as 2 exponent 2. So if I want to solve for x, I want to be left with x only on the left-hand side. I only want to have x here. So what must I do? It means this exponent here, I must multiply the exponent there by what? By 3 over 2. It's reciprocal. We've got 2 over 3. The reciprocal thereof will be 3 over 2. And remember the golden rule in maths. What you do on the left, you must also do on the right. So if you multiply by 3 over 2 here, on the left, even on the right-hand side, we must also multiply by 3 over 2. So that 2 and 2 cancels off, 3 and 3 cancels off. You are only left with 1 as an exponent. So on this side, you'll be have 2 exponent, 3, because this is 2 over 1. This 2 is 2 over 1. So 2 will cancel that 2. You'll only be left with 2 exponent 3, which is equals to 8. Then that will be the value of x. Let's practice. Mathematics needs to be practiced, and practice makes perfect. That is an exponential equation. Maybe I should give you another example of an exponential equation. Check this paper. Check another paper here. An example of exponential equations, because this is basically relatively new compared to the previous years. Check 1.1.3. Check 1.1.3. It's one of the papers that we exposed to. The first question solved for x. It was x minus 3 plus 8 over x. You notice the similarity. Even the example that I was using, we had a fraction, and you just multiply throughout by LCD. Check the second one, 3x squared plus 7x minus 2 equals 0. In case you find it difficult to factorize, go for quadratic formula. Use the quadratic formula to solve 1.1.2. 1.1.3 then becomes an exponential equation. Let's check out this one. Exponential equation 1.1.3, which is slightly different from the one that we solved earlier. Transpose x's to the left. You've got 2 multiplied by 3 exponent x plus 3 exponent x exponent minus 1, which is equals to 63. What did I do? This is, I've got minus 3 exponent x minus 1. I transposed it to the left. Now it looks like this. This is the same as 2 multiplied by 3 exponent x plus 3 exponent x, 3 exponent negative 1, which gives you 63. So we can already see a common factor. We can already see we've got a common factor. We've got 3 exponent x here. We also have got 3 exponent x there. So what we need to do, we take out 3 exponent x as a common factor. 3 exponent x as a common factor. Then what are you left with? If you take out 3 exponent x here, you're left with 2. Sorry for that. You are left with 2 plus. If you take out 3 exponent x here, you are left with 3 exponent minus 1, which will give you 63. Because we only, on the left-hand side, we only took out a common factor. So now we start solving for x. Remember, 3 exponent x, 2, 3 exponent minus 1 is the same as 1 over 3. Then it gives you 63. So all you have to do, you say 2 plus 3 over 3, I think is 3 multiplied by 2, it will be 7 over 3. If you add the 2. If you add 2 plus 1 over 3, the answer will then be 7 over 3. So this is the answer. Let's say it's 3 exponent x. In here, we've got 7 over 3, which still gives you 63. How if you solve x? On the left-hand side, we want to be left with x only. So what do? We multiply both sides by 3 over 7. You've got 7 over 3. We multiply by the reciprocal of 7 over 3, which is 3 over 7. And remember, what you do on the left, you should also do on the right. So you've got 3 exponent x, exponent 7 over 3. What do? I multiply this side by 3 over 7. I multiply by 7. So what I do on the left, I also do on the right. Even here, I've got 63 multiplied by 3 over 7. So that 7 will cancel 7, 3 will cancel 3. You'll only left with 3 exponent x. So you work it out. 63. 63, you multiply by 3 over 7. Work it out properly, I think it'll give you 27. So now it becomes easy for everyone. 3 exponent x squares of 3 exponent 3. Because exponential equations, remember, we need to ensure that the bases are the same. And once the bases are the same, you equate the exponents. Therefore, x will be equals to 3. Thank you very much. These are some of the questions that we should expect at the end of the year paper. Check this one. The quadratic inequality. This one is an inequality. It's not necessarily a quadratic inequality. Inequality. Remember, I said algebra and equations, including the inequalities, plus or minus 25 marks. That is an inequality. Then we just have to solve for x. We need this one is for 2 marks. We need understanding of that, of what the question expects from us. Like once you've got 3 exponent x, it does not matter. It does not matter the value of x, but this fraction 3 exponent x is always positive. You've got 3 exponent x multiplied by x minus 5 less than 0. You solve for x in that case. The understanding is that we've got 3 as a base, x as an exponent. So no matter the value of x, this fraction 3 exponent x will always be greater than 0. It will always be positive. Can substitute x by 0. It will be 3 exponent 0, it's 1. X by 2, 3 exponent 2 is positive 9. You can substitute x by negative 1. 3 exponent negative 1 will give you 1 over 3, which is positive. So whatever value you substitute for x, that fraction will be positive. What are we looking for? We're saying 3 exponent x, you multiply by x minus 5 must be less than 0. So if this one is already positive, for us to get a negative, anything less than 0, it means this one must be less than 0. Hence, if we solve this one, we say x minus 5 must be less than 0. Then x should be less than 5. This will be the solution just for 2 marks. But what is key is the understanding. 3 exponent x is always positive. It's an inequality, this one, not necessarily a quadratic inequality. If I have to show you another example on inequalities, even though I may not solve it because of time, let me just say this is what you should expect. Check this one. 1.1.4. X plus 3, 3 minus 2x greater or equal to 0. We need to solve x even in that case. That's a quadratic inequality. So definitely, come September, these are the questions that we know for sure they will be there. In case you learners, you're trying to practice and you're finding it some challenges, please don't hesitate to consult a teacher. September exam, remember, it contributes 25% to SBA. So it's very much important. We need to do well. Our June performance was not good, so we cannot keep on with that performance. We as Free Staters, we want to maintain our position 1. Thank you. Another question that we know for sure that will be the simultaneous equations. Any simultaneous equation, and what is key with regard to simultaneous equations, just make sure that you've got 2 equations. From one equation, you make one unknown the substituted formula. You make x the substituted formula. So in this case, it becomes so easy if you make x the substituted formula. Check, you've got x minus 2y minus 1 is equals to 0. So how do we solve that one? The key, just make x the subject of the formula. It's minus 2y, transpose it to the right, positive 2y, minus 1, transpose it to the right, plus 1. Then you just substitute this one to the second equation. Simultaneous equations, learners, still going to be there. Immediately after the simultaneous equations, what is it that we can expect? Exponents. Question relating to exponents, like this one. Like this one. Solve. Simplify completely without the use of a calculator. Simplify completely without the use of a calculator. Check. So these are the questions that we should expect. If I were to simplify this one, 1.3.1, square root of 2 minus the square root of 3 plus square root of 3 multiplied by the square root of 8. Squared this one, squared. You need to square this one. You need to square this one. Let's see what happens when you square. When you square this one, have 2. This one you multiply by this, and then multiply by 2. got minus 2, the square root of 2 multiplied by the square root of 3. You square the last one. If you square it, it's going to be plus 3. Here you've got the square root of 3 multiplied by the square root of 8. Square root of 3 multiplied by the square root of 8 is the same as the square root of 24. Because 8 multiplied by 3 will also give you 24. Or even this one, 8. You can say the square root of 3. Check the square root of 8. So you can see it's 4 multiplied by 2. Let's simplify it further. Then let's see what we have. 2, let's add the easy ones, 2 and 3. I think we can add the 2. 2 plus 3 will give you 5. Then here you've got minus 2, the square root of 2, the square root of 3. The square root of 3. This one, if I'm sorry, we've done a mistake. We cannot subtract here. Cannot subtract here. Can I rectify that one? I'm sorry for that. I'm very, very much sorry. Check, you've got 2 minus 2, the square root of 2, the square root of 3, plus 3, the square root of 3, multiply that. Let's simplify this one. Or maybe you can say this one to be square root of 6 and see what happens. Comes a bit easier. Check, it's 2 minus root 2 multiplied by the square root of 3. Remember, we've got 2. The square root of 2 multiplied by the square root of 3, the same as the square root of 6. Plus 3, the square root of 3. Check the square root form. The square root of 4 is 2. And then 2 is an irrational, root 2. Let's simplify it further. It's 2 minus 2, the square root of 6. Plus, let's multiply here, 3 and 2. 3 and 2 will give you 6. Then square root of 3 and the square root of 2 will also give you the square root of 6. This will be the answer. 2 minus 2, the square root of 6, plus 6, the square root of 6. Then we have plus 4, the square root of 6. These are some of those problems that are a bit challenging, level 4 questions more especially. Because learners do make mistakes more especially when they have to remove the exponent there. Thank you very much. The next one, more or less, check 1.3.2. Almost, it's basically sets. Almost similar. It requires the thorough understanding of the exponents. Let's do it quickly. 1.3.2. Square root of 12. Remember, square root of 12, you can see it's 4 multiplied by 3. Because 4 multiplied by 3 will give you 12. Minus. Check 75. 75 is the same as 25 multiplied by 3. This is all over. Let's write this in set form. If you write this 3 exponent 3 over 2 in set form, then you've got the square root of 3 exponent 3 in set form, because 2 comes here, it's a square root, which ultimately leads to square root of 27. Check. The square root of 4 is 2. This one is irrational, leave it as it is. Minus 25 is irrational. Square root of 25 is 5. 3 is irrational, leave it like that, all over. Remember, 3 exponent 3 gives us 27. And 27 is the same as 9 multiplied by 3. Square root of 9 multiplied by 3. Because 9 multiplied by 3 will give you 27, which is 3 exponent 3. Next step. 2 the square root of 3 minus 5 the square root of 3. You subtract this, those are the like terms. Then you will be left with minus 3 the square root of 3. All over. What is the square root of 9? It's 3 over square root of 3. So you simplify it further, ultimately the answer becomes 1. These are the exponential expressions that we need to know how to simplify them. These are some of the exponential expressions that we need to know how to simplify them. Thank you. That is more or less about question 1. I hope you get a picture. If I were to use this paper as well to try and show you what we had on exponents in this paper, check question 1. This was the exponent that appeared in this paper for 3 marks. Simplify without the use of a calculator. There it is. And if you simply have got the square root of 3, remember 48. 48 is the same as 16 multiplied by 3. Minus 4 is the same as 2 exponent 2. X plus 1 all over 2 exponent 2x. Just for a minute, this is the square root of 3. 16 is a rational number. So the square root of 16 will then give you 4. 3 is irrational. Minus, let's multiply throughout. 2 exponent 2x plus 2 all over 2 exponent 2x. We've got 4. This 4. Here is that 4. Write it down as it is. Square root of 3, square root of 3, they give you 3 if you multiply. Minus, this one, remember, is 2 exponent 2x, 2 exponent 2 all over 2 exponent 2x. So you can see if you simplify this one, this 2 exponent 2x will cancel that 2 exponent 2x. What are you left with? 4 multiplied by 3, which is 12, minus 2 exponent 2, which is 4. Ultimately, the answer becomes 8. Thank you. I think question 1 we have said mouthful. We've said mouthful about question 1. I think everyone must be ready for question 1. So let's have a very short break, 10 minutes break, and after that break, we can then now start continuing and looking at the next session, the possible questions that we should expect. But in as far as question 1, I hope everyone is clear of what to expect. So learners, let's do our part. I want to appeal to you, especially learners. Teachers, keep on assisting our learners, but you learners as well, please do your part. Play your role. It is your future we're talking about here, and mathematics will open ways for you. On that note, let's have a 10 minutes break. After 10 minutes, let's continue with more tips relating to mathematics to see exactly what to expect in September examination as well as the end of the year exam. When we enter the examination room, everything must be familiar. We must be familiar with everything. We shouldn't be surprised when we see a question. We must be ready for that. On that note, let's have a break and we'll continue after 10 minutes. Thank you very much. Welcome everyone. I think we have had a very nice break and we enjoyed our break. Welcome everyone. Because of time, we just have to immediately start working. We only left with about 50 minutes, so we should immediately start working. Another possible question from paper 1, quadratic number pattern. Quadratic number pattern. Quadratic number pattern is a pattern whereby the second difference is common. Those are the key concepts that learners should know. Every question that is related to quadratic number pattern, for you to determine the solution thereof, whether you determine the value of A, whether you determine Dn, Tn, whether you determine anything, whatever you determine X, you determine Y, as long as it's a quadratic number pattern, in one way or the other, we must come to a stage where we say the second difference is common. That will lead us to the solution of such problems. So in as far as quadratic number pattern is concerned, learners must know that the second difference is common. If I were to make an example of the one that is displayed there, a quadratic number pattern Tn is given as a first term equals to 1. You've got the quadratic number pattern, and it's given that the first term is 1. That is the first term. What is the second term? We don't know. What is the third term? We don't know. Fourth term and so forth, we do not know. But we know the first term is given. It's 1. The general term for the first difference. Remember the first difference. Here is the first. This is how we determine the first difference. We must be familiar with that. That is how we determine the first difference. And what is given in this case is the general term for the first difference. The general term is given as Tn. Tn is equals to 4n plus 6. For the first difference here, the terms that come here, the general term is 4n plus 6. So if you want to determine this one, you must determine T1. It will be 4 into 1 plus 6. The first difference here, it will be 4 into 1 plus 6. So this gives you 10. So it means we have 10 here. And by merely looking at 4n, it means the common difference is 4. So if you have 10 here, then here we must have 14, there we'll have 18, and then we ultimately have 22 as our first differences. How do we determine this? We use the given general term. The general term for the first differences is given by 4n plus 6. So first differences is 4n plus 6. The first one, substitute by 1. 4 into 1 plus 6. So it's 10. The second one, you substitute 2 here. 4 multiplied by 2, 8. 8 plus 6 will give you 14. Third one, 4 multiplied by 3 is 12. 12 plus 6, 18. Or in short, once you've determined the first one, you can tell the common difference is 4. You just keep on adding 4. 10 plus 4, 14 plus 4, 18 plus 4, 22. It's given that this is a quadratic number pattern. The statement, a quadratic number pattern with that general term. So if it's a quadratic number pattern, it means the second difference must be common. Let's check the second difference. The second difference here is 14 minus 10 gives you 4. 18 minus 14, 4. See, it's common. 22 minus 18, 4. So the second difference is common. Second difference is common in this case. And the second difference is 4. We haven't yet even answered the attempt to read the first question, but by merely analyzing, we get the picture. And we can even write down the sequence. But let's go to the question and see what the questions require from us. The first question, determine the value of A. Remember what is given. We are given the nth term. We are given Tn is equal to an squared plus bn plus c. The question now, determine the value of A. How do we determine the value of A? We say 2A is equals to 4, the second difference. 2A is equals to the second difference. That is how we determine A. Therefore, A will be equals to 2. It's answered. We have answered 3.1.1. Determine the value of A. The A will be equals to, check the following one, 3.1.2. Determine the formula for Tn. Now that we've got A, it's easy to determine the formula for Tn because Tn is given as an squared plus bn plus c. It's given. The question states a quadratic number pattern, Tn is equals to an squared plus bn plus c. So 3.1.2 states determine the formula for the nth term. It means we already have the value of A here. The value of A is 2. The value of A is 2. So all we need to do is determine the value of B and the value of C. And to determine all those, we only use the first terms. That's all. This one will help you to find A. This one will help you to find A. This one helps you to find B. This one helps you to find C. Let's see how. Let's find the value of B. Remember, to find B, this is what we normally do. 3A plus B is equals to 10. 3A plus B is equals to 10. This 10. Now that we already know the value of A is 2, we substitute here 3 multiplied by 2 plus B is equals to 10. So 3 multiplied by 2 gives you 6. This 6, you transpose it to the right. Therefore, you'll have 10 minus 6, which will give you 4. Now let's determine the value of C. Remember, I said this one will then help you to find the value of C. Remember the formula, A plus B plus C must give us the first term of the quadratic number pattern. Now we just substitute. What is the value of A? What is the value of A is 2. What is the value of B? It's 4. We want the value of C, then have 1. So you transpose everything to the right. 2 and 4 gives you 6. Transpose, go to 1 minus 6, which will give you negative 5. Now you've got the value of A, you've got the value of B, you've got the value of C. You can write down the nth term as 2n squared plus 4n minus 5. That will be the nth term of that quadratic number pattern. Quadratic number pattern is going to be there. It's going to be there in the exam. Fine. Another example of a quadratic number pattern, because of time I won't go through it, but I believe that everyone is familiar. Most special learners are familiar with it. Check the quadratic number pattern here, displayed. The sequence, minus 6, x, 10, y, 50. It's a quadratic sequence. The first question, calculate x and y for 8 marks. Calculate the nth term of the sequence. All that I'm saying is that first determine the first difference, then the second difference. And remember, the key with regard to quadratic number pattern or the quadratic sequence is that the second difference is common. You will never go wrong with quadratic number pattern. As long as you know that the second difference is common, you won't go wrong. Remember, the section that I'm talking about now takes plus or minus 25 marks. Sequence patterns, sequences, and series, like I indicated at the beginning of the session, they take plus or minus 25 marks. Other questions will then be related to arithmetic and geometric series. I think quadratic number pattern, you've got an idea. And when coming to the other questions, geometric and arithmetic sequence, check this one. Just an example. Just an example to say what is it that we should expect at the end of the year exam or in trial examination. What is it that we should expect? Check. I'm not going to solve them. I'm just going to say this is what we should be expecting. The following sequence is given: 27, 20, 17, 14. Sorry. The following sequence is given: 20, 17, and 14. Already, by merely looking at the sequence, you can tell that that is an arithmetic sequence. You determine the first difference. 17 minus 20 is 3. It's negative 3. 14 minus 17 is negative 3. So already you can tell this is an arithmetic sequence. And then once it is an arithmetic sequence, it means all the questions 3.1.1, 3.1.2, 3.1.3 will all have to apply the formulae for arithmetic sequence. Any question under the 3.1, we're given the arithmetic sequence. So the subsequent questions, the sub-questions of 3.1 will then be based on arithmetic sequence. And you as learner, you must then now start recalling all the formulae for the arithmetic. You know the nth term of arithmetic. You know the summing arithmetic. Those are the two crucial formulae that you should know. I'm saying the nth term Tn, A plus n minus 1 D. You must know that Sn is equal to n over 2, 2a plus n minus 1 into d. Thank you. That is another formula for summing and arithmetic. Of course, you can use Sn is equal to n over 2 into a plus l, where a represents the last term. This one. Sn is equal to n over 2 into a plus l, where l represents the last term, depending on the nature of the sequence that is given. But these are the formulae that should come to your mind. And I believe with this formulae, you can answer all the 3 questions. Because already you could tell that it's an arithmetic sequence. Expect that, and let's do our best. Let me show you this subsequent one, the next one. The sign, once you see sigma, sum. Once you see that sign, it's sum. It's a sigma sign, but it denotes your sum. You add all, you add. Thank you. The first question, write down the first 3 terms of the series. Calculate the sum of the series. All you have to do, expand the series. We don't know what kind of a series it is. Substitute. Firstly, n, you must start with this value. N, start with 1, put 1 there, then 2, then 3, and so forth up to infinity. How many terms are there? Infinite number of terms. So you're already going to determine the sum to infinity. So n, you put 1 there, simplify, put 2 there, simplify, put 3, and then you've got the sequence. And then you'll be able to tell what kind of a sequence it is. So this is one of the possible questions. And remember, when coming to sequences and series, like I emphasized the issue of arithmetic and geometric, there is this crucial one, sum to infinity. Sum to infinity. And we need to know the golden rule. When do we have sum to infinity? Once we have a convergent series. By a convergent series, that's when we find that the constant ratio R is less than 1, is between minus 1 and 1. And R is not equal to 0. And R should not be equal to 0. Sorry. R should not be equal to 0. Then we know Once we have the solution like this, then we know we've got a sum to infinity. Sum to infinity meaning every time when you keep on adding the terms, what does that mean? The sum approaches a certain number. As a result, R, the constant ratio, becomes between -1 and 1, and it's not equal to 0. We approach a particular value. Keep on adding the sum. You approach a particular value. Then we talk of a sum to infinity. Please, it is not difficult, because almost in every paper since the introduction of NCS, since 2008 papers up until now, every time, every question, it has got the sum to infinity. So teachers, expose them to this kind of problem, please. That's my appeal. Expose them to sum to infinity. Let them go and do some exercise on their own at home, and even in the classroom. Give learners problems on the chalkboard. Tell them within 2 minutes, give me the solution to this. They must write the solution on their books. I think this is the time where learners must start doing the work themselves. They must take the initiative. They must start writing. We cannot afford a situation whereby we always give learners solutions. They don't have time to write out the solutions on their own. Or if you give them homework to do, sometimes they copy it from others. So in the class, put the problem there on the board. Tell them it's 1 mark. For a minute, they must give you an answer. The next one, 3 minutes. At most 2 to 3 minutes, they must give you an answer. That's how we should get our learners engaged. And then we move around as teachers to monitor what they are doing, so that whenever they go wrong, we advise them accordingly. Sequencing a series, remember, said plus or minus 25 marks. That is a question that we should also expect. Thank you. Let me go to functions. Remember, functions, that is a topic that has indicated to you, it carries about 35 marks. It's a lot. 35 marks is a lot on functions. Check that question. Even before I talk of functions, automatically we've got four functions: linear function, quadratic function, exponential, and hyperbolic. Definitely, one of the questions, we have to draw the graph. We have to draw the graph. And you know, you must know the mother function, the original. You must know the mother function. By merely looking at this one, say question 4, you can tell that it's an exponential function. And already the picture, you must have the picture to say this is how the graph will look like. We haven't even started drawing the graph, but this is how the graph should look like. You should have the picture. And then calculate the coordinates of the y-intercept, x-intercept, and then you draw the graph. But what is also not asked in this question, the first 4.1.1 states, calculate the coordinates of the y-intercept. 4.1.2, calculate the coordinates of the x-intercept. But you as learners, you must know that for us to draw a hyperbolic function, we need at least 4 things: x-intercept, y-intercept, horizontal asymptote, as well as vertical asymptote. So familiarize with those basic requirements in each graph, basic properties of each graph. For you to draw a hyperbolic function, we need 4 things: x-intercept, y-intercept, vertical asymptote, and horizontal asymptote. If the graph was exponential, what do we do in exponential? X-intercept, y-intercept, and horizontal. What is it? Vertical asymptote. Know those properties. If it was a parabola, x-intercept, y-intercept, turning point is key. Turning point is key in case of a quadratic function. Let's know the basic properties of these graphs. Once you know the basic properties, you won't go wrong. You won't go wrong. And I always say, even if the question is difficult, you cannot answer the question. Check this one. If I were to make an example, calculate the coordinates of the y-intercept. For y-intercept, we know the equation is the equation that is given is f of x, which is equals to 2 over x plus 1 minus 3. The first question, calculate the coordinates of the y-intercept. Just by saying for y-intercept, x is equals to 0. That is a mark. For just saying for y-intercept x is equals to 0, and then you substitute x by 0. For x-intercept y is 0. All those, you need to do all those. Be familiar with those. Because crafts like this, we have drawn them grade 10, grade 11, even in grade 12, we're still drawing them. Let's do our part. Let us do our part. This is one of the possible questions. I know September, the only thing I'm not sure of is which graph are we going to be asked to draw. But between exponential, quadratic, and hyperbola, the question, one of those three graphs, we have to go and draw. In this example that I'm indicating here, we were required to draw hyperbolic function, the hyperbola. I'm saying come November, come September, trial examination or final end of the year paper, one of the two papers, we're going to draw the graph. I'm not sure which graph, whether it's exponential, whether it's quadratic, or hyperbola. The three graphs. We must know how to draw the graphs, know the basic properties. Know the basic properties. To say, if I draw a quadratic, these are the requirements. If I draw exponential, these are the requirements. If I draw hyperbolic, these are the requirements. You need to know those basic properties. And basically, I regard these questions as level 1 question. Because definitely, if you cannot draw a graph, it's a level 1 question. You must know the properties. What is it that we need to draw a particular function? Other questions relating to range, at least asymptotes, interpretation of graph, they can be a bit challenging. But drawing the graph, we must get that one right. We must get that one right. Thank you. We've got an example of 4.2 days. What is given is an exponential graph. It's an exponential graph. F at x equals to a multiplied by b exponent x plus q. It's an exponential graph. Know the properties of an exponential graph. Already, if the equation is given in that form, even before you read the question, definitely one of the questions is going to be determine the value of a and q. You determine the equation, you will be given 1 point. Practice makes perfect. Let's expect such questions in functions. One other question that we should also expect, where 2 or more graphs are drawn on the same set of axes, and then we interpret or we even determine the equation. In this case, the example that I'm having right now, I've got the quadratic function, parabola, minus 2x squared minus 5x plus 3, and the straight line ax plus q. Without even reading the question, one of the questions is going to say, determine the equation of g. Determine the equation of g. It's one of the questions that has to be there. Check 5.3. Hence or otherwise, determine the equation of g. What is g? The straight line, ax plus q. And from analytical geometry, I think we have done a lot in trying to determine the equation of a line. Any method is acceptable. Any method of determining the equation of a straight line. So we've got a quadratic function here as well as the linear functions. Those functions have been drawn on the same set of axes. So we need to interpret them. Those are the questions that we should expect. And this one, I say this is level 3 to 4. In questions like this, then level 3 to 4. Problem solving and complex procedures, if you remember them very well. Level 3 and 4. That's where we should expect questions from that level in graphs like this. But level 1, draw a graph. Level 1, draw. We know we're going to draw hyperbola, exponential, or hyperbola, parabola, or exponential. One of the graphs we're going to have to go and draw. So we must familiarize ourselves with the properties so that when we come up to these questions, which requires level 3 or 4, then at least we make sure that we have already collected marks. I hope we are understanding each other. I hope we are still together. This is more or less the type of questions that one should expect in the end of the year exam as well as in September examination. Learners, practice. I know you've got previous papers. Practice, practice, practice. We always say practice makes perfect. Thank you. If I were to make an example, again, check this one from another paper. It was in question 5. You were given an exponential graph. Write down the domain and the range of the graph. Write down the equation of the inverse in that form. Inverse functions. Inverse functions. And remember, when coming to the inverses, you just swap x and y. But in this case, we must be familiar. The inverse of exponential is log. This question always 13 marks. But the basics like domain, range, and the equation of the inverse, and even drawing the inverse, out of 13, learners must be able to come up with at least 7, because those are the basics. Then when coming to the questions relating to the reflections and so forth, then it's a bit challenging. But our learners who are performing at level 2, 3, they must get the basics correct. And once you get the basics, level 1, level 2, you will end up with level 3 or level 4 at the end of the year. Cognitive levels, remember, knowledge, routine procedures, complex procedures, problem solving. This is where the levels are a bit mixed, but the most important thing, we know how to write an inverse of a function. You just exchange x and y. And remember, in exponential form, you must change from exponent to log and vice versa. Functions, plus or minus 35 marks. Please, let us not be surprised. We know one of the 3 functions we are going to draw. Once you have drawn one of those 3 functions, the 3 functions I'm talking about, parabola, hyperbola, and exponential graph. Going to draw. The other one, functions will be drawn on the same set of axes. Parabola and hyperbola, whatever. But graphs will be drawn on the same set of axes, like this one. We shouldn't be shocked. This is what you should expect at the end of the year, even in the September exam. These are the questions that we must familiarize ourselves with. Not all questions are level 4 or level 3. We still have level 2 questions, because once you see a parabola, in one way or the other, you must determine the turning point. Once you see a parabola, in one way or the other, you must determine the x-intercept. Those are the basics that we should collect marks on, the basic properties. Thank you. I think functions, I've said mouthful. Functions, I've said mouthful. Another topic that I want to talk about right now, if I